Let's recap from yesterday. A card is drawn from a deck, the suit is recorded, and the card is returned to the deck. That is important. We have 10 trials, so my number of outcomes is 10. The number of times in those 10 trials that I yielded a diamond was once. So the experimental probability of drawing a diamond was 1 in 10, or 0.1, or 10%. Let's compare that to our theoretical probability of selecting a diamond. So theoretically, there are 52 cards in a deck. Each suit has 13 of those cards because there's 4 suits in a deck. And so that means that the probability of drawing a diamond will be 13 of 52. So the probability of drawing a diamond theoretically would be 13 of 52, or 1/4. So we have a lower probability in our experimental experiment than we had in our theoretical probability. A card is drawn from a deck. What's the probability that it is either red or black? Well, these 4 suits, if you guys aren't familiar, there's 2 red suits and 2 black suits. So the number of red is 26 and the number of black is also 26. So going back to our question, we're looking at what is the probability that is either red or black. So I'm hoping that you guys remember that this word or means and. Sorry, it means add, not and. And means multiply, or means add. So the probability of it being red is 26 over 52. The probability of it being black is 26 over 52. When we add those together, we get 52 over 52, or 100%. I hope that makes sense, considering there are only red or black cards in a deck of cards. This is going to be a refresher of combinations versus permutations. So a focus group of 3 members is to be randomly selected from a medical team consisting of 5 doctors, 2 nurses, and 7 technicians. So what is the probability? So we're selecting, we are not assigning roles. So as soon as we are not assigning roles, right, randomly, sorry, I didn't mean to do that. Randomly selected, okay, so that is a combination. So when we're looking for probabilities of things happening, in order to get our sample set, we have to look at, okay, so what would the possibility be with no restrictions versus what would the possibility be with restrictions as pertaining to the question? So the total number of people that we have in our group that we could select from, 5 doctors, 2 nurses, 7 technicians. So we've got 14 people total. The total number of ways that I can choose 3 members from those 14 people would be 14 choose 3. That is a total of 364 possible ways to randomly select 3 people from 14. So 364 ways. So don't be confused with, oh wait, no, but I only had 14 people to choose from. Right, but we're only choosing 3 of them, so we have to choose 3 from 14. And what's the total number of ways we can do that without restrictions? Now, the question here is, what's the probability of it consisting only of doctors? Well, now we have to look at how many ways can I choose 3 from 5 doctors. So if I have 5 doctors and I choose 3, I have 10 different ways that I can do that. So now the probability of it being doctors only is 5 choose 3 over 14 choose 3. So this is really important when we're doing probability. Is one of the biggest things is how are we selecting our sample size, and how are we, like, what are all the ways we can select for our sample size, and what are all the ways that we can select for any restriction, like the number of doctors. So what's the probability that the focus group will not be comprised of doctors only? Since we have the probability of doctors only, the fastest way to do this would be the indirect method, because the sum of doctors only and not doctors only has to equal 1. Or since, like I said, since we figured that out, it's just 100% minus the probability of doctors only, which was only 2.7%. So the probability of not doctors only is actually 97.3%, which is pretty high, which is good. Today we're talking about the difference between odds and probability. We often colloquially will say odds when we mean probability, and in data management, we have to be very, very, very specific. Are we talking about probability, or are we talking about odds? Odds and probability are not the same thing. Odds are another way to express a level of confidence of an outcome, and it's a ratio, not a percentage. So the odds of a ratio of success to failure. So it's just like the probability of something happening versus the probability of it not. The odds of something happening and the odds of it not happening make up the total number of ways something could happen. There are two ways to look at odds. You have odds in favor or you have odds against. And these two things are different. So we need to express odds as a ratio, not as a fraction. And you can't multiply or add odds. They have to be done by probability and then converted to odds. So the probability of something happening in a ratio of the probability of it not happening. Again, those two things need to add to 1. And then the number of outcomes of something happening versus the number of outcomes of it not happening relates to the odds and the probability, but in two different ways. Let's look at an example. So the odds in favor of the Voden, not HP, volleyball team winning a match is 50-1. Think about odds like ratios, right? Because they're set up as a ratio. I like to use my squirrel question. If the ratio of squirrels in my backyard, I have 4 gray squirrels to 1 red squirrel in my backyard, how many squirrels does there have to be for that ratio to exist? Well, I have to have 5. Same thing with odds. So if the odds in favor of Voden volleyball team winning a match is 50-1, it means that, so the odds of them winning, on average, they would win 50 games and only lose 1 out of 51 games, right? So if I have a 50-1 or a 10-2, it means that I have to add those two things together to figure out how many outcomes there would be. So the number of outcomes of an odd is the odds added together. Mr. Johnson's sock drawer contains 3 red socks, 5 white socks, and 4 blue socks. What are the odds in favor of him randomly drawing a pair of matching colored socks? So we've got socks in a drawer. Apparently we don't keep them in pairs. What are the odds of us randomly drawing a matching pair of socks? Just like most word problems, we have to set up some variables. So we're going to let event A be odds in favor of drawing a pair of matching color socks. So the opposing side to that would be not drawing 2 matching pairs of socks. So we have to figure out what are all the different ways that we can choose 2 matching socks based on the random socks that we have. So we've got 3 red socks, 5 white socks, and 4 blue socks. So we are just, a sock is a sock. So our socks are not being assigned any role. This is choosing. So it's not super tricky, but it needs some thought because I've got red socks, white socks, and blue socks. All of them can make a pair. So I have to figure out the number of ways that I can choose 2 of 3, the number of ways I can choose 2 of 5, sorry, I wrote 6, I'm gonna fix that, and the number of ways I can choose 2 of 4, 2, the number of ways I can have no restrictions, just randomly pull 2 socks from the drawer, they don't have to be matching, minus the number of ways I can choose equal or matching pairs. Also remember that OR means add. So 3 choose 2, plus 5 choose 2, plus 4 choose 2. When I add those all up, it's 19. 12 choose 2 is 66, minus the number of ways I could get the 3 choose 2, 5 choose 2, or 4 choose 2. And so my odds of choosing matching socks versus not matching socks is 19-47. And remember, the 19-47 is the odds in favor because 19 is the favorable outcome, 47 is the unfavorable outcome. Order matters when we are looking at odds. If the chance of having a snowstorm occurring in St. Thomas in March is estimated at 0.4, so the chance is probability. So that means that the probability of having a snowstorm in March in St. Thomas is 0.4 or 40%. It asks, what are the odds against having a snowstorm in March? So now the order of the ratio has to be against versus in favor. The sock drawer was in favor versus against. So the probability of no snow is 1 minus 0.4 or 60%. If there's a 40% chance of snow, that means there's a 60% chance of no snow, which means that the odds against having snow is 6-4. And notice how my probability has 10 in the denominator, but my odds have 6 and 4 adding to the denominator of my probability. Now, I also want you to know that we should be reducing our ratios to lowest terms. And so the odds against Snow and March is 6 to 4, or we should reduce that to 3 to 2. So that's gone from probability to odds. Now let's go from odds back to probability. So professor states that the odds of passing an exam are 8 to 1 when a student attends all classes. So again, if we want to think of these odds as people passing versus people not, that says that the odds of passing the exam, 8 people will pass the exam versus 1 who will not for students who attended all classes. So how many people have to be there to have an 8 to 1 ratio? That means we need to have at least 9 people present for the ratio to exist. Again, we need to set up our variables. So our event A is going to be the odds of someone passing, which means that the counter to that is the odds of somebody not passing on the other side of the ratio. But remember that we get our sample size from adding the number of event A to the number of event A prime, or the number of events of it not happening. Like I say, I like to keep equating it back to my squirrel question. If I have a ratio of squirrels in my backyard of 8 to 1, I have to have 9 squirrels in order for that to happen. So when the odds are 8 to 1 of passing, that means that the probability of passing is 8 over 9. Or you have a pretty good chance of passing in this class because you've got an 88.8% chance of passing if you attend all of the classes. Suppose the odds of Toronto Maple Leafs winning the Stanley Cup are 1 to 5. While the odds of the Montreal Canadiens winning the Stanley Cup are 2 to 13. What are the odds in favor of either Toronto or Montreal winning the Stanley Cup? Oh wait, remember there's an or in there, which means we're going to be adding. So first, the thing is, we have to turn this into a probability first, because remember, I cannot add or multiply odds. They have to be probabilities. So if there's a 1 in 5 chance that the Leafs are going to win, that means that the probability of the Leafs winning is 1 over 6. And just a point of clarification here. So remember, I got the denominator for Toronto, the probability of Toronto wins of 1 plus 5, and the denominator for Montreal wins as 2 plus 13. Thinking squirrels again. But we also have to acknowledge that the probability of them both winning is 0 because they cannot both win. And so a probability of Toronto or Montreal winning is going to be, so we have to look at the probability of Toronto plus the probability of Montreal winning minus the probability of Toronto and Montreal winning. And since we know that the probability of them both winning is 0, we don't have to worry too much about that. So the odds of 1 over 6, the probability of Toronto or Montreal is 1/6 plus 2/15. Get a common denominator, add them together, we get 9 over 30. So therefore, the odds in favor of Toronto or Montreal winning, remember that event A is either of them winning. So the number of times that either of them is going to win is 9, but the total sample set is 30. So the odds in favor of Toronto or Montreal winning is 9 to 21 or 3 to 7. And you now have time to go and please work on some of your practice questions.